As we venture into Women's History Month, I want to talk about one of my favorite female mathematicians who didn't even know she was a mathematician, Marjorie Rice. Hi, I'm Gabrielle Burchak. I have a background in math, science, and journalism, and by the time you're done listening to this, you will know so much more about a woman who left a clever imprint, pun intended, on the study of tessellations. In the year 415, the infamous philosopher and mathematician Hypatia of Alexandria, Egypt, was savagely murdered by church monks. This murder shocked the Roman community and its government leaders. Hypatia was known far and wide as a respected philosopher, mathematician, government advisor, and a professor. Hypatia, The Sum of Her Life, is a book that I wrote that looks not just at the circumstances surrounding her death, but also at the sum of her entire life. I weave in the details of her education, disciples, Neoplatonic philosophies, female contemporaries, and the many mathematics that she wrote and taught about. There is truly more to Hypatia's life than her death. Hypatia, The Sum of Her Life, written by me, Gabrielle Burchak, is now on sale on Amazon. Buy your copy today. Imagine a woman, a mom, sitting at her kitchen table, surrounded by stacks of scrap paper. A quiet hum of everyday life swirls around her. Still, she's deep in thought. Her pencil is tracing intricate pentagons over and over. It seems like a simple pastime, but in reality, she is rewriting mathematical history. At that moment, Marjorie Rice, a self-taught mathematician with no formal training, was about to change a field that had long been dominated by the most prestigious universities and scholars. She saw patterns where others saw impossibility, and her discoveries would soon challenge the very foundation of geometric symmetry. Marjorie Rice, née Juke, was born in Florida in 1923. She grew up in an era when opportunities for women in math were scarce. She was intelligent for her age. She studied in a one-room school but skipped 2 grades and was allowed to study with the older students. She was never able to attend college because her family couldn't afford it. She married in 1945 to a gentleman named Gilbert Rice. They left Florida for Washington, D.C., where Gilbert worked in a military hospital. To bring in extra money for the young couple, Rice worked as a commercial artist briefly until they moved to San Diego, California with their infant son, who sadly passed away. She went on to have 5 more kids. So while she showed an aptitude for numbers, her formal education never extended beyond high school. Instead of pursuing higher education, she married young, altruistically dedicating herself to family life as a wife and mother. Her days were filled with the routines of domestic life that included caring for her kids, running a household, and managing the countless responsibilities that come with it. Being a mom is truly a full-time job. Mathematics, at least academically, was far from her world. She had an inquisitive mind. In the 1970s, amid the everyday rhythm of her life, Rice's mathematical journey began. At the time, she had no reason to believe she would ever contribute to mathematics, let alone make a discovery that would stand alongside the work of professional mathematicians. But a simple spark of curiosity changed everything. She had purchased a subscription to Scientific American. The purchase was under the guise of a gift for her son, but while her kids were at school, she would pore over the magazine and specifically look forward to reading Martin Gardner's column titled Mathematical Games. Martin Gardner was a renowned science writer and a popularizer of recreational mathematics. His column captivated readers by presenting fascinating mathematical puzzles and problems that were accessible yet deeply complex. His work inspired generations of mathematicians, logicians, and puzzle enthusiasts. In 1975, Rice came across one of Gardner's articles that focused on the tiling of the plane using convex pentagons. This topic has fascinated mathematicians for decades because while squares, triangles, and hexagons can easily tile the plane, meaning they can cover a flat surface without gaps or overlaps, pentagons are trickier. At the time, mathematicians believed they had identified all the types of pentagons that could tile the plane, and the consensus was that only 5 such classes existed. Rice found herself captivated by this problem. Something about the idea of tiling, the way shapes fit together, and the hidden order behind seemingly complex patterns sparked her imagination. She was not a mathematician by trade, but a keen observer and a puzzle solver at heart. The idea that only 5 types of pentagons could tile the plane didn't sit right with her. She felt there was more to the story and that something had been overlooked. With no formal training beyond high school algebra, she evaluated the problem herself. Most people might have been deterred by the lack of credentials, but Rice was not most people. She had a natural sense of wonder and persistence that defied the limitations of traditional education. Armed with a pencil, some paper, and an insatiable curiosity, she began sketching pentagons on scraps of papers at her kitchen table, exploring their potential to tessellate. She devised her own notation system to keep track of her findings, using symbols and methods entirely of her own making. She wasn't burdened by the conventions of formal mathematical training. In some ways, her lack of conventions was an advantage. She approached the problem with a fresh perspective, unencumbered by assumptions. She would sketch pentagons, test their arrangements, and search for patterns for hours. What started as a puzzle of interest soon became a quiet obsession. And the interesting thing about this is that some of her relatives and loved ones would see her drawing in the kitchen, and they thought she was just doodling. They had no idea that she was solving a mathematical problem that even professionals couldn't solve. Rice's intuition led her to question what the experts had accepted as fact. Could it really be that only 5 types of convex pentagons could tile the plane? As she worked, she began uncovering new possibilities, pentagons that no one had previously classified. With every discovery, her excitement grew. Oh my gosh, who wouldn't get excited? She wasn't just playing with patterns, she was pushing the boundaries of mathematical knowledge. Rice, a valuable and devoted homemaker with no advanced education in math, was about to challenge an established belief in the mathematical world, and she was doing it from her kitchen table, immersing herself in the world of math and discovering a love for learning that would give her a mental reprieve from making school lunches and cleaning the house. And who likes to clean the house? I don't know about you, but I'd rather be doing math. As a mom and a mathematician, I get it. Math is by far the most extraordinary escape. Rice's inquisitive mind was not confined by degrees or formal training, and she would soon venture into an extraordinary discovery. Her journey was only beginning. By the late 1970s, Rice had made remarkable progress in her study of pentagonal tiling. Through sheer determination and ingenuity, she discovered 4 new types of pentagonal tilings, which was an astonishing feat considering that prior to her work, mathematicians believed they had identified all possible types. Excited about her revelations, she wrote to Martin Gardner to show him her discoveries. Gardner then forwarded her work to mathematics professor, Escher scholar, and tessellation expert Doris Schatzschneider, who would help validate and amplify Rice's contributions. At first, Schatzschneider was skeptical. After all, Rice was an amateur with no formal mathematical training. But when she examined Rice's careful, systematic approach and precise geometric notation, she realized that Rice had indeed uncovered new tiling patterns that had eluded professional mathematicians. Schatzschneider took it upon herself to verify Rice's findings and present them to the academic world. Rice's first introduction to the academic world was through Schatzschneider's first article on her titled In Praise of Amateurs in Mathematics magazine in 1977. In Schatzschneider's second article in 1978, titled Tiling the Plane with Congruent Pentagons, co-authored with Richard Guy and published in Mathematics magazine, Schatzschneider not only confirmed the validity of Rice's work, but also expanded the known classification of pentagonal tilings significantly. As a result, This defied the scientific community's stance that no new tilings could be created. Rice's work increased the number of known convex pentagonal tilings from 8 to 12. Her work altered the future studies of tessellation studies. Beyond the mathematical significance, the recognition of Rice's work had a broader impact on the perception of amateur contributions to mathematics. Historically, mathematics was a field reserved for those with advanced degrees and formal training. Historically, mathematics was a male-dominated field, reserved for those with advanced degrees and formal training. Rice's success challenged this notion, proving that independent researchers with enough curiosity and perseverance could make substantial contributions. Her story became an inspiring example of how intellectual discovery is not limited to the halls of academia. Rice and Schatzschneider continued to collaborate in numerous ways. Schatzschneider helped refine Rice's notation and ensured her work could be understood within the broader mathematical discourse. The legacy of Marjorie Rice extends beyond the pentagons she discovered. Her work inspired others to look more closely at tiling problems and contributed to a renewed interest in the role of amateurs in math research. Today, her pentagonal tilings are studied in mathematical curricula and remain essential to tessellation theory. Her journey, one that began with a single Scientific American article, demonstrates the power of curiosity and the unexpected places it can lead. So what were the methods that Marjorie Rice used? Well, her mathematical process was meticulous and inventive. It was built on a combination of geometric reasoning, pattern recognition, and self-taught methods. Lacking formal academic training in higher mathematics, she developed her own notation system, and she used logical deduction to analyze pentagonal tilings. One of Rice's key strategies was geometric reasoning. She systematically examined pentagonal properties, identifying relationships between angles and side lengths that allow seamless tiling. Unlike trained mathematicians who might approach the problem with established formulas, Rice used a hands-on approach, sketching pentagons by hand and testing their fit. To organize her findings, she developed her own custom notation system. This notation allowed her to track angle relationships and tiling patterns efficiently. Without the formal language of topology or advanced geometry, she created her own shorthand for describing and classifying pentagons based on their ability to tessellate. And if you're interested in seeing her writing and her analysis and the way she used her shorthand, please come visit me at mathsciencehistory.com because it's really, really cool and it's exciting because for me, it takes me back to when I first started learning math before I started learning math in college. And I kind of did similar things to understand geometry and math. So, and also, while you're at my website, Math Science History, please click on that coffee button and buy a cup of coffee, any size, any amount, because every donation that you make to the podcast goes a long way in helping to pay for production costs. So back to the podcast. Rice also relied on basic algebra and trigonometry. She calculated angles and analyzed the geometric properties of pentagons, ensuring that new types she discovered could fit within known tessellation patterns. Though she did not use advanced mathematical tools, her logical approach paralleled the methodologies used by professional mathematicians. Another critical aspect of her process was pattern recognition and iteration, testing different pentagonal shapes and refining her approach through repeated trial and error. This persistence led her to discover 4 new types of pentagonal tilings, something that had eluded trained mathematicians for decades. Rice's methods exemplify the power of independent mathematical inquiry. Her discoveries, validated by professionals like Doris Schatzschneider, reshaped the understanding of pentagonal tiling and demonstrated that significant mathematical contributions can come from from unexpected places. Marjorie Rice's story highlights the importance of diverse perspectives in mathematics. As a woman without formal training, her contributions defied expectations and demonstrated that mathematical breakthroughs can emerge outside of the academic world. Her success is a testament to the value of independent exploration and the impact of intellectual curiosity. Throughout history, many women have made profound contributions to mathematics, often teaching themselves or overcoming significant barriers to do so. For example, Mary Everest Boole, a self-taught mathematician, transformed mathematical education by pioneering visualization and hands-on learning techniques for children. Florence Nightingale, widely known as a nurse, was also a statistician who revolutionized data visualization using her innovative pie charts to influence healthcare policies. Katherine Johnson, one of my favorite sheroes in the world of math, though formally trained, faced barriers as an African-American woman, but went on to make crucial calculations for NASA's early space missions. Similarly, despite her formal education, Joan Clark was frequently overlooked due to her gender. Still, she played an essential role in breaking the German Enigma code during World War II. These women defied societal norms and left a lasting impact on mathematics and beyond. Math is not reserved for the privileged few who receive formal education. Math belongs to anyone with curiosity, determination, and a desire to understand the world. Whether through self-teaching, unconventional learning methods, or sheer persistence, anyone can unlock the beauty and power of mathematics. All of these women defied societal norms and left a lasting impact on math and beyond. The stories of Mary Everest Boole, Florence Nightingale, Katherine Johnson, and Joan Clark reminds us that barriers are meant to be broken and that the pursuit of knowledge knows no bounds. If you have ever doubted your ability to engage with math, let their legacies inspire you to explore, question, and discover. The language of numbers, patterns, and logic is waiting for you to make your mark. Marjorie Rice's story is a testament to the boundless nature of human curiosity. Without formal training, she reshaped the landscape of mathematics, proving that discovery isn't confined to ivory towers or advanced degrees. Discover belongs to anyone with passion, perseverance, and a willingness to question the unknown. Her work in Pentagonal tiling continues to influence art, architecture, and science, reminding us that mathematical beauty isn't just found in textbooks. It can also be found in the world around us, which includes intricate tile mosaics and hidden patterns in nature, like a pineapple. And if you didn't see that video, be sure to visit my Fibonacci post on Instagram about math in a pineapple. It's true, math can be found in a pineapple. As we celebrate Women's History Month, let's recognize the impact of women like Marjorie Rice, who defied expectations and expanded the frontiers of knowledge. Rice's contributions challenged the status quo and reshaped our understanding of mathematical possibilities. However, perhaps the most important lesson from Marjorie Rice's journey is this: never let imposter syndrome or self-doubt silence your curiosity. She could have convinced herself she wasn't qualified, that she was just a homemaker without formal training. She could have ignored the spark of interest that led her to uncover new mathematical truths, but she didn't. She questioned, she explored, she discovered, and she fell in love with math. If you've ever felt like an imposter, like you don't belong in a particular space or conversation or even a university, remember this: you are where you are because of your brilliant mind. Breakthroughs don't always come from experts. Sometimes they come from those bold enough to ask, what if? The next great discovery might not come from a university lab, but from a kitchen table, a sketchbook, or a mind willing to see patterns where others see only chaos. So, to all the hidden mathematicians, artists, scientists, and dreamers out there, keep questioning, keep exploring, and And just like Marjorie Rice, never stop tiling your own path to discovery. Thank you for tuning in to Math, Science, History. And until next time, carpe diem. Thank you for joining me at Math, Science, History. Please remember to subscribe to the show. Also, if you could leave a rating or a review, I would truly appreciate that. Those ratings and reviews really help to increase my listenership, which help me get more sponsors and advertisers, which help me keep the podcast up and running. If you want to learn more about the history of math and science, please visit me at mathsciencehistory.com. There you can find the transcripts and additional information to each topic, as well as additional links to other sites. Oh, and hey, if you like what you're listening to, and you like what you're reading, please feel free to click on that cup of coffee and make a donation to the podcast, because every cup of coffee that you buy helps me to pay for the expenses that go into making this podcast. If you would like an early peek and listen to the podcast, you can follow me on Patreon, where you can choose a tier or even pick your own price. Or you can also subscribe to Math Science History on Medium, where you can read an early release of the podcast, which includes the math. Also, if you're interested in having me speak at your school or your event, please visit me at GabrielleBurchak.com. I would love to come share the world of math, science, and history with you, your audience, and your students. Finally, if you're interested in leaving me a comment or submitting a podcast topic, you can always find me and Math Science History on your preferred platforms, including Instagram, Facebook, LinkedIn, Blue Sky, or you can just search the Googly for Gabrielle Burchak. Until next time, carpe diem.